In this example, we're going to take a look at how to create a probability distribution for sample means. So just a reminder, the notation that we use for a sample mean is that notation X bar. So in this particular example, we have a population that's relatively small. It only has three values in it, the numbers 5, 8, and 12. And we want to choose two numbers at random from this population. And we want to choose those two numbers with replacement. So the first thing that we're going to do in question A is list all the possible samples of size n equals 2, meaning what are all the different ways that I can pick two numbers from that bowl that contains the numbers 5, 8, and 12. And then after we do that, we're going to calculate the mean for each of our samples. And you can see here that I've already stated that there are going to be 9 samples. So how do we know that there are only 9 ways of choosing two numbers from a population of 3 numbers? Well, let's start listing it and hopefully you can see. Um, when I have just three numbers, the numbers 5, 8, and 12, and I randomly choose two numbers, it is possible that I pick the number 5 and then pick the number 5 again. So that's my first possible sample of size n equals 2. But I could also pick the number 5 and then the number 8. So that's a potential sample of size n equals 2. I could also pick the number 5 and 12. So that's another possible sample of size 2. But I could also pick the number 8 and 5. I could also pick the number 8 and then 8 again. I can also pick the number 8 and 12. Okay, so we keep listing all the possible ways of picking two numbers from that bowl of three numbers. It's possible that I pick the number 12 and 5, or I could pick the number 12 and 8, or I could pick the number 12 and 12. So let's pause for a second and make sure that we have figured out all the possible ways of picking two numbers from that population of three numbers that include 5, 8, and 12. And I hope you can see here that there are only 9 ways of picking two numbers from that pool of three numbers. So then the next thing we do is we say, okay, every time that we pick a random, when we any time that we randomly pick two numbers from that population of three numbers, what are all the possible sample means that we could get? Well, if we choose the sample and get 5 and 5, then the sample mean from this sample is going to be 5 plus 5, which is 10 divided by 2, which gives me a sample mean of 5. If we get the second sample, 5 and 8, then the sample mean here will be 5 plus 8 divided by 2, or 6.5. If we keep going down the list here, if our sample contains the numbers 5 and 12, that gives us a sample mean of 8.5. And then let's keep going. If we get a sample 8 and 5, that gives us a sample mean of 6.5. 8 and 8 gives us a sample mean of 8. 8 and 12 gives us a sample mean of 10. 12 and 5 gives us a sample mean of 8.5. 12 and 8 gives us a sample mean of 10. And then 12 and 12 will give us a sample mean of 12. So in this second column here, you can see all the possible sample means that we could get, right, from these samples of size n equals 2. And so now that we've listed all the possible sample means, we can then create a probability distribution for the sample means. And the probability distribution, I'll show it in this table on the right here. So this will be question B. Let's summarize the mean for each of the 9 samples and then create a sampling distribution for those sample means in the form of a table. So if we take a look at all the potential sample means, we can see that we could get a sample mean of 5. So I'm going to go ahead and write that down as a sample mean for our sample size of n equals 2. But we could also have a sample mean of 6.5. We could also get a sample mean of 8. It's possible that we get a sample mean of 8.5, or we can get a sample mean of 10, or we can get a sample mean of 12. Okay? And so now when we take a look at the probability distribution, which is this column, P of X bar, the probability distribution represents the probability, the chance, or the likelihood that I pick two numbers from that bowl of three numbers and I get a sample mean of 5. Well, there's only one way of getting a sample mean of 5. The only way I can get a sample mean of 5 is if I get the sample that contains the number 5 and 5. And so there's only one way of getting that sample out of 9 possible ways of getting a sample of size n equals 2. So the probability distribution, or the probability for getting a sample mean of 5, there's only 1 out of 9 ways of getting that. So the probability is 1 out of 9. How many different ways can I get a sample mean of 6.5? If we take a look at the table again, to get 6.5, I would either have to get the sample of number 5 and 8, or if I pick the number 8 and 5, right? There are 2 ways that I can get a sample mean of 6.5. So that means that there are 2 out of 9 ways of picking 2 numbers and getting a sample mean of 6.5. So we keep going, right? What are all the possible ways of getting a sample mean of 8? Well, the only way I can get a sample mean of 8 is if I pick the number 8 and 8. So if I have that sample, 8 and 8, then I'll get a sample mean of 8. So there's only 1 out of 9 chance of getting a sample mean of 8. And then we keep going. How do we get a sample mean of 8.5? Well, that happens if I get a sample that contains the numbers 5 and 12. Okay, so that gives me 8.5. Or if I pick a sample that has the numbers 12 and 5, that will also give me a sample mean of 8.5. So there are 2 out of 9 ways of getting that sample mean. So that probability is 2 out of 9. The only way that I can get a sample mean of 10 is if I pick the number 8 and 12. So that sample 8 and 12 gives me a sample mean of 10. So there's only 1 out of 9 chances of that happening. Oh, no, I made a mistake. There's another way of getting a sample mean of 10 if I pick 12 and 8. So actually there are 2 ways. So I'm going to fix that. That's 2 out of 9. So there's 2 out of 9 ways of getting a sample mean of 10. And then there's only one way of getting a sample mean of 12. That's if I get the sample that contains the number 12 and 12. So that's 1 out of 9. So here in this column, we have the probability distribution for the sample means for this population that contains 3 numbers, the numbers 5, 8, and 12. So a couple things to check here, your probability distribution. So this last column here, all of those individual probabilities, they need to add up to the whole. So if I add up all the numerators, 1 plus 2 plus 1 plus 2 plus 2 plus 1, it adds back up to the whole. So that probability distribution, the sum, should add back up to 1.